Hi, welcome back to John Science and Principles. Previously we've looked at series and parallel circuits, but today what I want to look at is what if you combine the two, how would you deal with it? And for instance, I've got something to show you here, which is going to be a series parallel circuit. What you can see is a 2 ohm resistor connected to a parallel network of 10 ohms and 7 ohms. And essentially what we do is we'll work on the parallel network first and then create what we call an equivalent resistance out of them two, and then we can put it in series with the 2 ohms and that will give us the full resistance of that circuit. So let's get stuck into this. So if we look at the parallel section first, we remember that we had a 10 ohm resistor and a 7 ohm resistor in there. So considering that, what we'll do, if you remember, we've said 1 over Rp is going to equal 1 over R1 plus 1 over R2. So now if we start putting some figures into that, we can say 1 over Rp, and that's going to equal 1 over 7 plus 1 over 10. Now, if we get the calculator out and do some calculations, we can say that 1 over Rp, P for parallel of course, resistance parallel, and 1 divided by 7 will equal 0.14. Then plus 1 over 10, so if we say 1 divided by 10, that equals 0.1. So now we're starting to get somewhere. So we can say 1 over Rp is equal to 0.14 plus 0.1. So let's just pop them into the calculator. 0.14 plus 0.1, and that's going to equal 0.24. But we don't know what we don't want what 1 over Rp is, we want Rp. So Rp is going to equal 1 over 0.24. So we can say Rp, so Rp equals 1 divided by 0.24, and it equals 4.16 ohms. Don't forget the ohms. 4.16 ohms. So what we can say now is we'll have an equivalent resistance connected in series with the resistor that's already there. So the resistor already there is 2 ohms. So now what we can say is we've got our 2 ohm resistor connected in series with our equivalent resistor for the parallel network, which is 4.16 ohms. So our resistance total, so we can say resistance total of that circuit is going to equal 2 plus 4.16. So resistance total is going to equal 2 plus 4.16, and equals 6.16 ohms. So there's the calculations for the series parallel network. If you want to do that yourself and have a go, write this down. What I want you to do now is have a little go yourself. Here's a series parallel network. You can see here you've got a 5 ohm resistor connected with 2 resistors in parallel, which are 25 ohms and 30 ohms. So what I want you to do, if you now pause your film, you try and work out the calculation. I'll run through the sums with you in a little minute. So pause now and I'll be back soon. Okay, so I'm going to use the big board for this one now. So if you think about it, we can say 1 over RP. For the parallel network, first of all, is going to be 1 over R1 plus 1 over R2. So 1 over RP would equal 1 over 25 plus 1 over 30. So 1 over RP, that would equal 1 divided by 25, and that equals 0.04, plus 1 divided by 30, that equals 0.03. I'm just rounding these down to two significant figures. So 1 over RP is going to equal those two numbers added together. So that's 0.04 plus 0.03, and I'll give you 0.07. But as we said, we don't want 1 over RP, we want RP. So RP is going to equal 1 divided by 0.07. So RP, so the resistance in the parallel, is going to be 1 divided by 0.07. And it gives us 14.28 ohms. 14.28 omega. So we can say now then that we've got an equivalent circuit of that, and that will be our 5 ohm resistor in series with the 14.28 ohm resistor. So resistance total is equal to R1 plus R2 in series. So R total is going to equal 5 plus 14.28. We got a bit of 8. So RT is going to equal 5 plus 14.28, that equals 19.28 ohms. Oh, it's a rubbish ohm design. Oh, that's better. Ohms. Okay, so we've worked out that total resistance. Here's a little stretching task for you now. What I want you to try and tell me, and I'll give you 2 minutes to do it, is what voltage would you need in this circuit to drive a current through it of 5 amps. I'll give you 2 minutes to think about it, and then I'll go over just what I've said. So, what voltage would I need to drive a current of 5 amps through that circuit? Well, if you remember, we said Ohm's law, V for voltage is equal to I for current multiplied by R for resistance. So this is simple. We don't have to transpose the equation or anything like that. All we need to do is bang in our numbers. So our voltage is going to equal 5 for the current multiplied by the total circuit resistance, and that we said was 19.28 ohms. So now if we pop that in, we just do that multiplication and we say 5 times 19.28, and that's going to equal 96.4 volts. Isn't maths beautiful? So just by doing these maths and these equations, we found out that we found out the equivalent resistance to that circuit, and if we apply 96.4 volts through it, then we will drive a current of 5 amps through it. That's pretty much the end of today's lesson. But what I want to do in the next lesson is pick up the series parallel circuit again, and in that one we're going to do a calculation or a number of calculations to discover how the voltages and currents are shared between each individual component. Thank you very much.